Thank you. Afternoon, everyone. Thanks for joining us. My name is Ian Logan with 3C Ren and the County of Ventura Sustainability Division. Today we have Ann Edminster here to walk us through some steps that we can take as homeowners and occupants that increase our home's resilience in the face of wildfire and in turn also reduces our carbon footprint. Before diving in, I will just roll through a few housekeeping slides. So by now, I'm sure most of you are very familiar with Zoom. We ask that throughout the duration of the training, you remain on mute. If you would like to verbally participate, we'll either invite you to do so, or you can raise your hand in the participant section. Otherwise, we do encourage you to participate through the chat box. I will then relay your questions to Ann. Time permitting, we may have a short Q&A after, towards the end of the event. You're also welcome to follow up via email or however. For attendance purposes, if everyone can make sure that their screen name displays their first and last name, you're able to rename yourself by selecting the drop-down menu next to your tile or in the participant section. And lastly, the workshop today will be recorded for our on-demand page. If you'd like to remain anonymous, we suggest that you keep your video turned off. Next slide, please. Oh, I think, yeah, there are like a few boxes that come through. So just a few words about who we are. The Tri-County Regional Energy Network, also known as 3C Ren. We're a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties. Our purpose is to improve energy efficiency in the region by offering free programs and services for all building professionals and households. 3C Ren is funded by ratepayer dollars that we all pay into in our utility bills through the public goods charge. The benefit of being ratepayer funded is that there's no cost to those that we serve. And as a regional energy network, we're able to return those dollars back to our local economy that has historically missed out on some of these funds. Next slide, please. So you may notice a few of my colleagues on the call today with this, you'll recognize them with this background of Pierpont Bay and Ventura. Feel free to chat them directly if you have any questions about, learning units or slides, and as well, if you're having any technical issues, we can try to solve those also. Today's course is designed to be an introduction, so if there are any concepts or building techniques that have questions about, please don't hesitate to ask. With that, I will let Ann dive right in.
Thanks, Ian, and welcome everyone. Thank you for joining us at the end of your day. I hope everybody's still relatively fresh and enjoying sunshine and happy summer day wherever you are. So first, I would love to know who's in the audience. I know several of you. Welcome, friends. And Ian, I think will run this poll so we can find out who all's here. Oh, you guys are quick. That's great. Okay, looks like almost everybody's voted. Some of you are trying to decide what you are. I can relate to that. Okay, we can call it here, I think. So interesting. We have a mix. Share results. Okay, I guess those are being shared. So about evenly split between homeowners, general contractors, architects, and others. And Ian, do we have any answers in the chat box saying what the others are?
Let's see. I don't see anything now.
Okay, so we have mysteries. That's okay. Maybe we'll find out more as we go. Okay, so moving right along. Thank you for filling me in on that. I've got 3 sections here this evening. First on definitions and benefits, then on the electric upgrade options, and finally making a transition plan. And these are the second and third sections have a little bit of repetition in terms of the themes, but I'm giving more tips in the second or the final section about sort of process. So that's the main distinction here. So finally, it's late in my day, definitions. Electrification, what we mean by that is transitioning away from appliances and equipment that are fueled by natural gas or propane. You'll note that I've put natural in quotation marks. That turns out that the terminology natural gas has really been used primarily by the gas industry to purvey the idea that this is something healthy, like natural foods. And of course, many of you probably realize that natural foods is somewhat nonsensical term because there's no regulations around it. And it really is, it's used to convey an idea without anything really being attached to that. There's no legs to it, no teeth to use of the definition. So the gas industry has really used this to purvey the notion that this is healthy. And what we know now is it's actually quite unhealthy. So when we talk electrification, the four main uses in homes that we're talking about converting are heating with electricity, which generally means we're able to cool at the same time, water heating, cooking, and clothes drying. And we'll be walking through all of those. The benefits of electrifying are numerous. First, we're decreasing the indoor air pollution substantially, reducing kitchen safety risks. Actually, my son came home from his job yesterday. He works with young people with special needs in their homes, and they had had an episode where an older gas stove had been used and then not completely turned off, and everyone went outside for a while, came back in after 20 minutes, and the whole house smelled of gas. It was pretty scary, and that would not happen in an all-electric kitchen. There are numerous other kitchen safety risks that are reduced by going to electric, and I'll probably talk about those maybe multiple times because it's really a favorite theme of mine in the arena of electrification. Improved equipment. So anytime we're replacing older equipment with new, generally the equipment comes with newer improved features, often with improved efficiency as well as better safety and many other nice things that we like. Usually they're aesthetic improvements, controls improvements, features, and so forth. So I remember in my older home, I first moved into it, well over 30 years ago, I guess about 35 years ago. And it was equipped with definitely older appliances. And I celebrated the death of each one because then I got to get something new that had many more features I liked. So this is certainly not the least important, although it may affect us in the most indirect ways, but reducing the greenhouse gas emissions is a big point of this, and it's why it's of such interest to 3C Ren and to many of us that we are in a climate crisis, as I'm sure you all know, and all looking to find ways to improve our climate profiles. So an all-electric home is not an insignificant way to address that. So going to an all-electric home means emitting about 40% less greenhouse gas than an equivalent home that is powered by natural gas. This is research that comes from SMUD, the Sacramento Municipal Utility District, which is one of the agencies within the state that has been doing some of the most progressive work in this area. And they've got a bunch of great resources. The link is on this slide. By the way, there are a number of links throughout this presentation, live links. And so the slides will be shared with you after the presentation. So you won't need to take notes or say, now what was that long URL, or try to write it down. So you'll be able to go back to all of these links and refer to them afterwards. And then finally, last but not least, for many folks, it's very important that going to electrification means avoiding the inevitable increases in gas pricing that will occur in the years and decades to come. As the state pursues its climate goals, what that's going to mean is less and less provision and maintenance of natural gas infrastructure, and the state will be diverting more attention towards electrification. So with fewer customers on gas, that means fewer people sharing the cost of maintaining that very expensive infrastructure. So really critical piece of that. Okay, now before we move into other specifics about electrification, I wanted to talk about efficiency. There are several reasons why efficiency is ideally and whenever possible a precursor to going all electric. So we'll talk a little bit about that and its benefits. So first of which is improved comfort indoors. Whenever we make a building more efficient, particularly the enclosure features, we are improving indoor comfort, temperature stability, and so forth. We're reducing overall energy use, which brings costs down. And as I mentioned in the prior slide, with the inevitable electric rate increases, it's important that we don't just shift our energy use from one fuel to another, but also reduce it, because electric rates are typically higher than gas rates. So what we want to do is shift from one fuel to the other and at the same time reduce overall usage so that we don't experience adverse rate increases. Okay, and then the other really important aspect of efficiency is it improves resiliency. So you like my bouncing balls there? I love to have images because I think they really help cement ideas. And this one I thought was really fun. So, but what do we mean by resiliency? It isn't playing in the park, although that's lovely. The benefits of efficiency that bring with them resiliency are stable indoor temperatures, which I already mentioned. Very important, particularly during power outages, which have become a feature of life for many of us here in fire-prone regions of California. And this is not just comfort, it's also a life safety feature, because with our increasing extreme temperatures, that means there are many people who have health challenges, who may be elderly, so the very old, the very young are particularly vulnerable to extreme temperatures, as are those with the health challenges. So this is not an insignificant thing. We're also, again, providing protection of indoor air quality. The efficiency measures that we employ on the enclosure mean less intrusion of wildfire smoke or other types of air quality problems that occur on the exterior. There are also enclosure improvements that reduce not only the wildfire smoke intrusion, but the risk of wildfire per se. So I'll be going into several of those things right now. One of the things that I find really exciting about this subject is the synergies that occur when we undertake a comprehensive retrofit that looks holistically at the connections between these things. So the image that I'm showing here and on the next couple of slides, these are from a project that I've worked on in the Oakland Hills, very close to the wildland urban interface. And this is a vintage 1970s home that was not constructed with a lot of attention to, honestly, either aesthetics or durability. The good news about that is when I was doing a lot of remodeling design, I used to tell my clients, think of demolition as opportunity. So when we see deterioration and things that need to be upgraded for a variety of reasons, they often open up opportunities to do things that do have multiple benefits. So in this particular case, the T111 siding is in very poor condition from nearly a half century of exposure to UV and driving rain and wind and so forth. So the owners are up for replacing that siding. Taking off the siding gives us the opportunity to air seal, which again is both a thermal benefit and a wildfire protection benefit, again, mostly smoke. We are installing new cavity insulation, which is primarily an efficiency benefit. We'll be adding non-combustible continuous exterior insulation. Because it's non-combustible, again, this is both a thermal benefit and a wildfire protection benefit. And then finally, non-combustible siding on top of all of the other items. So the final layer, if you will, in the fire resistance assembly. So a little bit more in the assemblies, the enclosure rather, we're also looking at the glazing here. And in this particular home, there was a combination of single pane glass and dual pane glass. However, even the dual pane glass, these were not thermally broken units, and they're pretty aged and are not well fitting within the window rough openings. So there is air leakage, which again means smoke leakage. So this homeowner is in the fortunate position of being able to afford window replacements. And so that's what's happening. All of the windows, even the dual glazed, are being replaced with dual glazed tempered wood windows that are clad with metal for durability. And all of them have compression closing. So the dual glazing is both a thermal benefit, which probably you all know as compared to single glaze. What you may not know is that dual glazing also is more fire resistant than single glazing. Tempering the glass, particularly both panes, further increases fire safety. And then avoiding vinyl in particular is important for fire, because vinyl in the face of fire, you will not be surprised to know, melts and deforms. And the deformation not only destroys the windows, but again, allows heat, smoke, and flame intrusion. The compression closing, and what I mean by that are windows that close with a clamp type of seal. So these are casement windows, the kind that hinge on the side and typically will crank open and closed. Awning windows, which generally open outward with the hinges above, and hoppers, which are hinged on the lower edge and then hinge outward. So all of these types of windows are clamped closed. What this means is they're inherently more tight and therefore better to avoid the intrusion of air, which is a thermal benefit, and smoky air, which is an air quality benefit, and any kind of sparks that may come through cracks. Now, windows that slide, which are incredibly common, of course, whether they're what we call, quote, sliders, including sliding doors, or double hung and single hung windows, which slide vertically up and down. Those, by their nature, have to be somewhat loose because that's what allows them to slide. So that's why we prefer the compression close over the sliding units. So that's a little tutorial on glazing and why it matters from both thermal and a fire perspective. Time for some water. Yet another aspect of the enclosure that we can improve is the venting. So in this home, we're going to be eliminating the vents both in the roof and the crawl space. And this, again, dual benefit. You're going to hear me singing the same song over and over again. That improves the thermal performance of the home. It also reduces the opportunities for the intrusion of smoke, embers, and flames. So when we do that, when we convert a crawl space, basement, or a roof from a vented to an unvented space, what we're doing, what we need to do is actually change where the insulation occurs so that that enclosed space now is insulated. So in the attic, we move the insulation from the ceiling plane up to the roof plane. In the crawl space, instead of insulating under the floor, we're looking at insulating the crawl space walls. What we now have are what we call semi-conditioned spaces. So we're not directly heating or cooling those spaces, but they're inherently going to be cooler in the summer, warmer in the winter than previously when they were uninsulated. This makes them really great places to put heating and cooling systems, which will perform a lot more efficiently than they would have previously in those uninsulated spaces. So in this particular home, that's exactly what we're doing. There was no floor insulation whatsoever. There was old and very deteriorated insulation at the ceiling. So those are situations that needed to be remedied in any case. And as I mentioned, the home being close to the wildland urban interface, having these vents was definitely a risk factor. So that's all changing. And at the same time, an additional goal for this homeowner was, in fact, to electrify. So we're replacing their existing natural gas water heater, which is in the crawl space, their existing natural gas furnace, which was in the crawl space, again, exposed for all intents and purposes to exterior temperatures and therefore really compromising performance. We're putting in new heat pumps, mini split heat pumps, one in the crawl space and one in the attic with the ducting. And so they will all now be in this semi-conditioned space and operating much more efficiently than their prior counterparts. So there are a lot of synergies to, again, looking at these systems together and what the opportunities are. Moving beyond the enclosure to ventilation as distinct from venting. So venting is basically poking holes in things and letting the air move in and out. Ventilation is actually thinking about how we supply fresh air for us to breathe within homes. This is often a source of confusion for homeowners. So another opportunity afforded by creating these new semi-conditioned spaces is also to put in what are called ERVs, energy recovery ventilation systems, or HRVs, heat recovery ventilation systems, into these newly conditioned spaces. So this is very important because now what we can do is provide filtered fresh air rather than getting incidental or unfiltered fresh air or not so fresh air, which is what we often get when people say, I can just open the windows to get fresh air. Well, not in smoke season, you can't. And so we're finding more and more people interested in active ventilation systems than they ever have been before. And one of the concerns that often arises is, well, if I'm running a pump to get this fresh air moving in and out of my home, then that has an energy penalty. But it's not what you might think, because in our older, less airtight homes, we've been getting air movement between interior and exterior by passive, unintentional means. So in our older homes that were not air sealed, there are lots of very small, sometimes not so small, places where air is just leaking in from the exterior, but we don't know how much air we're getting. We don't know the quality of that air. We don't know the quantity. So it's not really a great way to provide air for our breathing. So this is another opportunity that's been created when we are looking at these types of retrofits.
And we have a quick question.
Yeah.
From Craig Lewis. He's asking if most jurisdictions allow unvented attics.
Yeah, that's a great question. They absolutely should, because this is perfectly permissible by codes nowadays. In the past, it was more of an issue. There are definitely still building officials and building inspectors who are not completely up to speed with unvented spaces. So it's not a bad idea to have a preemptive conversation with your local building department if this is something you're planning to do. And if you get any resistance, it's not too hard to come up with the supporting information, code sections, and also technical resources to help make the case that, yes, this is not only permitted, but desirable. One really great resource is buildingscience.com. They've got a ton of really authoritative information that can be used in conversations with building department folks. Okay, one more example from this particular project. No, not from this particular project, but from another one. And that is skylights. There are a lot of people who have kind of a romantic relationship with skylights. They let light into your house where otherwise it may sometimes be difficult to provide daylight, but they are definitely also a thermal challenge. So, and you'll see in my photo and diagram on the left, there's not only radiant heat gain during the day, but radiant heat loss at night. The night sky acts sort of like the opposite to the sun in the daytime. So you probably all experienced being outside on a winter's day, and yet even in snow country, and yet being perfectly warm and comfortable if you are in the sun. This is because the sun essentially beams heat directly to you when you're in a direct line of sight with it. Well, the dark night sky is sort of the inverse. And so it can essentially suck heat right out of your house through these windows in your roof. So this is little known fact. And I actually have friends I was visiting recently who have numerous skylights and were complaining of a lot of comfort problems and a lot of difficulty keeping their house warm enough. And I said, well, you know, those skylights are kind of a liability, so you might consider putting thermal shutters on them. But if you're looking at a roof replacement or considering adding solar, that's a great time to just think about the benefit versus risk or liability of skylights and whether there are maybe some other ways of getting skylights in. I've done some work with a builder in the Central Valley who, sorry, water time. I talked to at one point about using solar tubes, and he said, yeah, well, so he works for an affordable housing developer. He said, yeah, solar tubes are great, but you know what? I can install really great daylight spectrum LEDs for a fraction of the solar tubes and sorry, without poking holes in the roof. Hard to argue with that. It's not the same experience as daylight, but we definitely have more choices than we used to. So I really encourage people, sorry, especially looking at new construction, to just avoid skylights unless there's really not another good solution. I'm going to take a breath here. I'm wondering if I've got a little air quality problem that's making me hoarse. At any rate, going to an all-electric home also inherently improves resiliency. So what are the benefits here? We get power restored much faster after outages than with gas fuel. So I know some people say, well, if I go to all electric, I'm not going to be able to cook when the power goes out. That may be true. However, when we lose power, we often also lose power to our gas appliances because most of the new ones have electronics so that they can't really be used effectively in a power outage. And furthermore, when there are the types of emergencies that we have been exposed to in recent years, we're often looking at gas shutoffs as well as electric shutoffs. And the experience is documented that restoring electric power, depending on the nature of the emergency or the outage, can be in this range of a few hours to a few days. The time to restore gas service is in weeks or sometimes months. So again, sort of little known facts about this. When we eliminate gas, we eliminate on-site explosion risks. And if we also include distributed energy resources, meaning solar and battery, that's sort of the optimum combination, because then we have not only utility savings month over month from having those solar resources Solar also provides an increase in resale value that averages about 4% nationwide, clean carbon-free energy, and with power when the grid goes down with batteries. And I should also say, even without batteries, there's often the ability to provide power to limited items within the house just with solar. Boy, I'm really sorry about the hoarseness. This is not fun. At any rate, so I think I've shown that there's a real win-win of looking at efficiency, resiliency, and electrification together. So I just really want to encourage that holistic thinking. Moving on to the electric upgrade options. Before we do that, Ian, are there any other questions that might be addressed before I launch into this new section?
Yeah, we have a couple quick ones. Another one from Craig: is there a significant insulation efficiency difference between roof plane, ceiling batt, and blown attic cellulose?
Great question. Generally speaking, I'm not a huge fan of bats. Not that a good job can't be done with bats, but I'd say bats are a little bit more vulnerable to installation defects that occur primarily from the installers being pressured for time and working too fast. And because bats are challenging, you know, they're 14.5 inches wide to fit in framing cavities. But anybody who's looked at a newly framed house will tell you that the number of cavities that are actually 14.5 inches wide is quite small because of all the things that are being done in home design and building. And also there are lots of disruptions in exterior walls with wiring, plumbing, and so forth. So I'm not a big fan of bats for that reason. Not as big an issue in a ceiling necessarily as in exterior walls. Nevertheless, these issues do still occur. In terms of overall efficiency, a lot of it has to do with specifics of the home design and the depth of insulation that would be allowed based on the design specifics. So one of the nice things when we eliminate attic venting is at that point, we can make the insulation as deep as we need it to in the roof plane through these types of suspended methods where there's some, I'm trying to think where it's a good diagram of that. I could dig it up if somebody wants to see it. Craig, if you would like a diagram of the suspended methods where netting is dropped from the framing so you can have quite a bit more insulation than the depth of the roof joist would inherently allow. So that said, you know, we have different roof pitches and all kinds of challenges with roof configuration. So there's probably no single uniform answer. But yeah, depending on also the opportunity or not to put space conditioning equipment in an attic, there may be more or less compelling argument for moving the insulation from the ceiling to the attic plane. So again, all homes are tremendously variable, so no single solution. Any other questions before we move on?
Yes, one more. What do you mean by thermal shutters?
Oh, thermal shutters. Okay, so the idea is something that would cover the skylights either from interior or exterior, but interior is probably, generally speaking, more viable with an insulated object. So let's say simplest thing would be like a slab of foam that got stuffed up into the skylight well at night. But there are all kinds of things. I hate these noisemakers in my neighborhood. You'll see them, if you do a Google search, you'll probably see some where they've actually been permanent installations and hinged so that they might have two leaves and drop down into the skylight opening and then close up again at night with a sort of hinge and pulley system. Does that make sense?
Yeah, I think so.
Okay, great. All right, let's move on to the electric upgrade options. So we're looking at the principal systems I mentioned earlier, and a couple of bonuses here too. So for space heating, essentially there are two options, both of which are heat pumps. I'm showing a mini split on the left and a standard heat pump on the right. The split terminology just refers to the fact that there are two pieces of equipment. There's a compressor and an air handler. And what you're seeing in the photos on left and right are the compressors, which are exterior, and the air handlers are interior. And the center photo, what you see over the hallway, is a very discreetly installed air handler for a mini split. Now, mini splits can be either ducted or ductless. That will depend on the specific needs of, again, unique homes and their needs. The main differential between the two heat pump options is really the amount of heating and or cooling capacity required for the particular home. So mini split's going to have the lower capacity than a standard heat pump, and it's going to be better for smaller and or highly efficient spaces, whereas a standard heat pump is going to be more suitable for larger and or less efficient homes. And of course, when we're talking about electrifying, by definition, we're talking existing homes. Since if we're starting from scratch, we're not converting to electrification. We're hopefully going to start with all electric, but that means we're looking at how to get these things installed. Sorry. Conversions. So either option provide efficient and quiet heating and cooling. So for a home that's got natural gas or propane heat, we have many of these in California coastal zones where there is no cooling presently, and yet increasing temperatures are causing more and more people to wish they had cooling. So there's a real opportunity here to replace a furnace with a device that will provide both heating and cooling. So that's our first option, our first piece of equipment. For water heaters, once again, two options. On the left, heat pump water heater, on the right, tankless electric. And these are pretty different. Unlike, well, I'm not saying unlike, never mind. We'll just talk about them uniquely. The heat pump water heater is going to be more like a conventional water heater in that there's a tank that holds a certain amount of hot water, and when it's exhausted, it'll need to be filled and reheated again. The tankless is often referred to as an instantaneous. This is somewhat erroneous in that it's only instantaneous or really quick if it's mounted in direct proximity to the place where the hot water is needed. So, but there's a lot of misunderstanding about tankless units on the market. I think they're often viewed as kind of a panacea and sold as sort of an across the board green solution, when the reality is that they really need to be tailored to the installation. So if they're going to be installed as a replacement for a tank unit, there can be really significant performance challenges if there is quite a bit of travel distance between the tankless unit and the hot water draws. So there can be a real disappointment factor when the hot water is not delivered, quote, instantaneously. The other big deal, of course, they're much smaller. So that can be an important feature that lends them to particular spaces. And whereas heat pump water heaters are big old honking things, just like conventional tank water heaters. The big advantage of the heat pump water heaters is that they are, by and large, at least 3 times as efficient as the most efficient tankless unit. And this is because of the physics of the way heat pumps work. heat pumps borrow heat from the surrounding environment, so they don't have to create all that heat. They use the compression cycle, just the way refrigerators do, to move heat from one place to another. So we've got a couple of caveats here. Larger capacity than what you might have previously can be recommended for a heat pump water heater, because when they do run out of hot water, they won't necessarily regenerate that heated water as quickly as you've been accustomed to with the gas unit. So, and they do require some more airspace around them than a conventional unit does. So they may not always be a swap in, swap out approach. Also, you have to make sure there's adequate electrical service to, put an electric unit where a gas unit has been previously. So that is the general lowdown. And I just want to offer a comment here too, that this is kind of a 30,000-foot flyover view of these options. And I know that 3C Ren has much more detailed classes that go into just heat pump water heaters, for example, and just heat pump space conditioning. So for more information on those, definitely refer to those deeper classes, which are going to give a lot more technical information for those of you who are building practitioners. Whereas here, what I'm trying to do is really just kind of paint the whole landscape of what it means to electrify, and with a focus on existing homes. Okay, moving on to induction cooking. Now, it's certainly true that a conventional electric range is also a possible swap-in for a gas range, but I'm not even including those, because most people, when you even mention the prospect of cooking with electricity to them, scrunch their face up in a very unhappy expression, because they've had experiences in the past with the conventional electric coil ranges, which I don't think too many people really enjoyed cooking on. So I think this is really one of these, I hesitate to call it a wonder technology, but it really is a quantum leap beyond prior home cooking ranges. So I'm a big convert. You maybe got that idea already. I've been cooking with an induction range for the last 2 years and will never go back. Of course, my primary motivation was because I wanted to be in an all-electric, emissions-free home. But I've also been really excited and not ever remotely disappointed with it, because it's so much cleaner, so much safer, way less air quality problems, better controls. There's a cooler kitchen and cooking environment that comes with this. So there's absolutely nothing bad to say about this. One thing I should have included on this, I didn't. There's a really terrific resource website that I would encourage you all to look at, which is called The Switch Is On. So those, The Switch Is On, 4 words, all run together, theswitchison.org. Lots of great information about all these electrification technologies, and a lot of information also on the improved health and safety of cooking with induction. And there's just more and more information on this pouring out into the market and social media. So I would definitely encourage you to partake of that if you haven't already run across that information. So really, really wonderful. There is a learning curve, and this is, I would say, probably of the few complaints I've heard about induction, most of them have been that these induction units cook so much faster that people have burnt meals. And a few really extreme cases actually scorched their cookware. But really nothing that a little Bon Ami and a scrubby sponge won't take care of. But you really adapt very fast. The other thing is, people say, well, I'm really accustomed to looking at the flame. The flame tells me, if it's, where it needs to be to cook the particular dish I'm cooking. But really, if you think about it, the flame is just a visual indicator to you. It's not as though you know, for example, how hot that flame is, how much heat it's imparting to the pot at what rate. And all the induction units have similar visual indicators. So it's really just learning the same basic type of visual signal that you've already learned on a gas stove. It's just adapting. And I personally found it to be really, really fast, partly because the controls are so much more precise and faster in responding that when you change the setting on the induction range, you see the results almost immediately. If something's really sizzling like crazy and you bump it down a couple of notches, you see that result very quickly. So whereas on our older ranges, that they're not nearly as responsive. And so it's a lot harder to sort of say, well, did I get the right setting? Did I drop it too much? Did I not drop it enough? So anyway, I'm a big fan. And in the last few years, 2 or 3 years, Consumer Reports, of course, reports on ranges. In the last couple of years, all of their top marked ranges are induction. So that'll tell you something about the general state of the art in cooking technology. Moving on to clothes dryers. Once again, we have 2 options available to us, a standard electric and a heat pump. Standard electric behaves pretty much exactly as you would be accustomed to with a gas dryer. And a heat pump, same basic behavior, except that with the heat pump technology, it's quite a bit more efficient, so uses about half the energy. However, there is a corresponding increase in drying time. On the good news side of that, that means it's using a lower heat, and so that's gentler on clothes. So if there are a lot of delicate clothes being used in your household, then that could be really a benefit. Also, they don't require venting, so that could also be a benefit if there are some installation constraints. You'll also notice that in terms of price, the standard electric units at the low end of the price spectrum, quite a bit less expensive than a heat pump unit. At the high end of the spectrum, they're pretty much competitive price-wise. So if you're looking at the higher end of the price spectrum, then you really won't be paying a premium for a heat pump unit. And of course, just the visuals, they're, you know, a dryer is a dryer is a dryer. So it's not going to really have any effect aesthetically, although I think probably most of us don't think a lot about the aesthetics of our laundry equipment because we're tucking them in corners and closets for the most part because they're not super lovely objects. Okay, oh, one thing I will add too, there are also combination washer dryers that have heat pump drying. And the advantage there, they are smaller capacity. However, since the heat pump does take longer to dry the clothes, if you can put one load in and come back later when everything is finished, then the longer dry time may not be so much an issue. So for example, you could put a load in the morning before going to work and come back at the end of the day and it's all washed and dried. So that's another possibility to look at. Okay, so we're into the bonus realm too. We're past our top 4 essential functions in most homes, and we'll look at a couple more here, one being fireplaces. Because next to stoves, fireplaces are the item that people can get kind of emotional about when you talk about electrifying or eliminating gas. So we don't want to deprive people of that thing because we're human. Fire is elemental to our experience as human beings. So there are some substitutions. There are electric so-called fireplaces. Sorry, something's making strange noises outside my door. And some of them actually even produce heat, but they're amazingly aesthetically convincing in terms of the look of flame. So if it's mainly that sort of flickering look that evokes a psychological response that you're after, lots of really beautiful and lots of design flexibility in the options available in the electric fire appliance realm. They range from pretty reasonable cost up into the stratosphere, depending on what you're looking for. Now, on the right, I'm showing my personal favorite approach that's quite economical and certainly has to be used with great discretion, because we don't want to be using things like a chimenea or any type of outdoor fireplace when there is any type of wildfire risk. So that's a definite caveat. But if you really want a true flame experience, I would say take it outdoors where you won't have an indoor air quality disadvantage from that. And you can actually make s'mores on it, unlike the indoor option. So more limited, but I think, you know, we're all after a different type of aesthetic experience when it comes to a fireplace. So just want to offer some different perspectives on that. Now, on the more technical side of things, for heating pools and spas, we're not all fortunate enough to have pools and spas, but there are a lot of them out there. And there's more and more emphasis on converting those units from heating with natural gas or propane, which is quite typical, to heating with heat pumps. This is an area that is really emergent. So there's not yet a lot of experience and therefore not a lot of expertise in doing pool and spa heating with heat pumps. However, we've got some early stage projects that are starting to prove this out. We've got a handful of very competent mechanical engineers who can help with this for folks who really are committed to decarbonizing their homes completely. So you'll note my note at bottom left, adult supervision required. I definitely recommend working with an engineer who has experience with this. Our experience is in California is very different than in different parts of the country too. So I want to just emphasize that. I worked on a project a number of years ago, probably a decade plus, where the owners wanted to do exactly this and initially started working with an experienced pool designer from a different part of the country. And it ended up that that experience was not all that helpful, because it was part of the country where in the summer months when the pools were being used, it stayed pretty warm at night. That's not typically true in our coastal California areas. We can get blazing hot in the daytime and have significant temperature drop at night. And that will have a huge effect on our strategies for pool heating. So, and we do still have solar thermal options for both glazed and unglazed. This is going to be more suitable for summer only type heating, because the solar thermal typically won't keep up with the cooler season. So if there's a pool that needs heating outside the warm months, then solar thermal is probably not going to be adequate all by itself. So I've got a couple more resources for you here if you want to dig into this a little bit more. Now, renewable energy, it's not, you know, part of the efficiency equation, but I just want to mention this again. Two opportunities for acquiring renewable energy. The obvious, of course, is to have an on-site solar system of photovoltaics for solar electricity, but also more and more of the energy providers statewide, both are conventional utilities, and in many regions, community choice aggregators are offering 100% renewable energy or very close to it through a premium option. So in my home, I have both. I have on-site solar, and that covers about 60 or 70% of our load. And the home was built with that system. So rather than buying additional photovoltaics, what we've done is upgraded to the community choice aggregators premium 100% renewable, and in our case, locally produced energy, so that we have 100% clean energy. And I think we're really fortunate, those of us who are in California, that the community choice phenomenon is really spreading rapidly and giving us many more options than we had a few short years ago. So it's a really exciting transition we're seeing in the energy industry. And then batteries. So of course, the primary benefit that's top of mind for most people is to have backup power available for when the grid goes down, either for critical loads only, or in some cases for the entire home. And most battery systems now can be programmed to prioritize the critical loads and or to balance this backup power capability with what's called solar self-consumption. And solar self-consumption is what I would call more of a day in, day out operating mode. It's illustrated in the little graph at the bottom right, where when we have the sun is shining and producing more energy with rooftop photovoltaics than we need, that excess energy can go into the battery, which we can then tap when the sun goes down, rather than immediately reverting to utility power. So we can draw from our battery. And then in the case of a planned power outage, the programming in the batteries can be preferenced instead to not use, not go into that mode, but instead to conserve all of the stored energy for the household needs during the outage. Okay, that was the end of the second segment before moving into the third segment, the final segment. Ian, do we have any other questions or comments?
Yeah, we are looking for your thoughts on electric ovens.
Oh, sure. Well, what's interesting is actually for quite a long time, there have been combination ranges that have, say, a gas top and an electric oven. So more and more ranges have actually had electric ovens for quite some time. And, functionally, I really don't see any benefit of gas over an electric oven at all. So it's, again, the flame thing doesn't really play in electric ovens. Gas ovens, it's not as though people have used that to regulate ovens. They use the temperature gauge. So but I'm all in for electric ovens. And again, many people have become accustomed to them even while still cooking with gas on the stovetop.
Mm-hmm. And then, so do you have an opinion about solar roof tiles versus solar panels?
Well, I have some information, more information than opinions, I guess, a little of each. The latest from Tesla on their roof tiles is the installations are proving to be more challenging and therefore more expensive than they originally anticipated. So the whole Tesla roof tile thing, which looked very appealing and very sexy when they first introduced the idea, is proving to be a little more challenging to bring to fruition. Other solar roof tiles, honestly, I haven't even really seen in recent years. I feel as though the earlier attempts at solar roof tiles hit some obstacles much earlier on and have sort of faded into the background. The other issue that I see with solar roof tiles is, just the connectivity one to the other. That's an awful lot of little tiny connections to be making. So I'm not a big fan. Also, I think there was earlier sort of like peel and stick type of, not exactly roof tiles, but solar embedded in these sort of sticky matrix and applied to other roofing. There's a real potential differential in lifespan between that model of solar roof tile and the underlying roofing itself, which is not going to be really, I think, a great match. So I'm still in the roof panel, PV panels on top of roofs camp very solidly. I think it'll be a while before we get beyond that.
And then a quick follow-up on the electric ovens. Are they electric resistance?
Yes,
Okay.
yes. Many of them are combination conduction convection. However, and the adding the convection to a conventional electric oven can provide some benefits in terms of more even heating within the oven cavity, and then sometimes speeding up the cooking a little bit, not a lot. I've had a combination convection oven for probably at least 10 years, and I found a minor benefit in baking with the the convection option, but not much difference in other types of oven cooking.
Awesome. Thank you.
Sure. Okay, shall we go on to the transition plan? Yeah. Okay, here we go. So if you're thinking you're going to electrify, most people don't have the luxury or the appetite to do it all at once. So what I've done here is kind of outline the sequence that makes sense to me, with the caveat that, again, every home is to some extent unique. Every household is certainly unique. And so these are not meant to be 100% prescriptions, more a way of thinking about it and then customizing to your own situation and needs. So what I would recommend first is to think big picture and think, okay, well, electrifying, first of all, the four sort of standard equipment items that we ran through, and perhaps some of the others. But are you also maybe planning on some electric vehicles in your future? Electric vehicles, including e-bikes, for example. So all of those are going to add electric load. And are you maybe considering battery storage? So think about all of them, whether or not they're in your sort of short, middle, or medium term future. Then once you sort of have a sense of your ultimate destination, electrically speaking, I say go after some of the easy pieces. It's pretty easy to swap out lighting. And for those who have not yet gone to LEDs, I will say that the improvements in LED technology over the last even 5 years has been stunning. I mean, really dramatic. So early LEDs, for the longest time, it was actually really hard to find LED fixtures. And then they came along and they were really disappointing, both in terms of lighting quality and aesthetics of the fixtures themselves. Now there's just a ton of options, including very affordable and quite nice looking fixtures from myriad sources. So there is, in my view, no reason at all to hesitate on 100% LED conversion. Secondly, we have other easy things to do within smart thermostats and power strips. Now, I have colleagues who say, well, you don't really need a smart thermostat if you have a really efficient house. That may be true, but when we're talking about electrifying existing homes, very few of our existing homes are as efficient as we might love them to be if we were starting from scratch and getting to build them in the optimal way. So I think that smart thermostats have some real potential to help save energy and improve comfort at the same time. And then we've also got smart power strips, and just the photo I'm showing here, there are more and more options, different types available, different flexibility of control, and again, a certain amount of smarts in them to turn things off when they're not needed or not in use. And then, of course, any of our water fixtures that also rely on heating hot water for showers and faucets, we can benefit by replacing with EPA WaterSense labeled models. Particularly in a drought, it's great to have the dual benefit of saving energy and water at the same time. And there are quite a few water districts and water authorities that will either give you some of these items for free or give them to you at deeply discounted prices. One extra comment about shower heads. I always think it's worth noting that a lot of people have almost as much horror of a low flow shower head as they might have of an electric range. But there's flow rate on a shower head is actually a very poor indicator of the shower experience, because there's actually a lot of hydraulic design that goes into the specific performance of a unique shower head. So I have one colleague who's deep in this space as I am, and I joke about this and say there are a lot of us that belong to the Let's Try It at Home club. And so we have done a lot of these improvements in our own homes. And so Pete replaced a couple of shower heads in his house, different ones, to try them out. And there was one that he really liked and his wife hated, and the other one his wife really liked and he hated. So there's not necessarily going to be a uniform response to shower heads. The good news is they're pretty easy to install and deinstall, most of them. And if you don't like one, you can probably return it within 30 days. So give them a try and don't assume that low flow means low performance. Okay, moving up to something that's more expensive, more of an effort to replace, looking at appliances. And my absolute favorite resource is the one over on the right-hand side, marketplace.pge.com. So whether or not PG&E is your utility, you can utilize this resource. It's really running an engine. You'll see here in the middle of the screen. I don't know, can you guys see my cursor?
Yes.
Okay,
Yeah.
great. Bobbling around here. So Energy is the engine that's running this marketplace. There's also an Energy website per se, if for some reason, but it's not energy.com. It's got an odd prefix to it. So if for some reason that doesn't work for you, I can get the alternate URL. But last time I looked, it didn't really matter where you were. The main thing about it being on the PG&E website or running behind that URL is that it'll give you utility costs based on PG&E rates. Probably not the most important feature of the site. What I like about it is it gives you all this other information. It gives you consumer ratings. It gives you an efficiency score between 0 and 100, tells you, well, again, this is a utility territory specific feature, the rebate, and it gives you a price and links from multiple retailers. So it's also particularly for refrigerators, less important for most other appliances, which tend to be more standardized. You can actually use their incredibly powerful search engine to narrow your choices, not only by energy score. I like to recommend that you start with a minimum score of 90, see if you can find something that works for you there. And if not, drop it to 85, 80, and so forth, which is still pretty darn good. But you can also use the search engine to narrow by the dimensions. So because refrigerator sizes are all over the map, and some are counter depth and some stick out pretty far, and some are built-ins and some are not. So you can put all kinds of different parameters into your search to come up with things that meet your needs. The other thing I want to draw attention to on this particular screen is the blue logo on the left for the Energy Star Most Efficient. So for many years, it was really felt that Energy Star was sort of the pinnacle of energy performance. But a few years ago, the EPA actually tacitly acknowledged that that was not the case, because Energy Star got to be almost just a baseline across the board in the industry. So they introduced this new label of Energy Star Most Efficient. So I would definitely encourage you to also reference that. And then this third resource here is CEE1.org, is the Consortium for Energy Efficiency. They also list appliances. So these are all good resources to use to look at when you're interested in replacing items. There are also other options, other types of devices you can shop for in the marketplace or Energy, including home electronics. which can also be a significant source of energy draw. Okay, so we've taken care of the easy stuff. Now we move into things that are a little bit harder. I mentioned earlier on in the presentation that it's important whenever we can to improve the efficiency of the building itself so that when we switch to electric devices, we're not just jacking up our utility costs. So, and the enclosure is really the first line of defense. That said, it can also be kind of challenging to get at and to deal with in existing homes. You'll notice that I've listed walls last because walls are often the hardest thing to insulate in an existing home. So I would always say start at the attic. Often we can improve the both the amount and the quality of the installation of attic insulation. Oftentimes in California homes, there is no insulation below floors. So that's also can be a fruitful area. Although I was looking at a home recently where the crawl space was so small that much as I wished I could recommend they insulate under the floors, I honestly could not see a viable way of doing that. So it's, again, homes are unique. You have to sort of take all these bits of advice and adjust as needed for your own circumstances. But before any insulation improvements, it's really important to consider the air sealing, because this is something that's really been poorly understood and as a consequence neglected historically in our existing homes. We really didn't understand the significance of air leakage and how much it compromises the performance of our insulation. So that is definitely the first thing to look at when any type of insulation or enclosure improvement is under consideration, is how do we air seal first, close up those little and larger leaks and gaps, and then put in a well-installed, modest to large amount of insulation to improve the existing enclosure. And I also mentioned windows, so a little bit more technical information on window replacements. What you'll see on the right here is called the NFRC label. This is the National Fenestration Rating Council, and it typically displays these 4 parameters, each of which reflects a different aspect of the window's performance. The 2 most important from an energy perspective are the 2 I've shown boxed in red. So the U factor. U factor is the inverse, effectively inverse of R factor. So a lot of folks, even who are outside the industry, have gotten accustomed to using the language of R factor when talking about insulation. It stands for thermal resistance. And for when we talk about wall, floor, ceiling insulation, R values, a bigger number means more thermal resistance or better thermal performance. So for example, we like to look at an R value of, let's say 40 and above is great for attics. Say around 20 is pretty darn good for walls and so forth. Well, U factor, because it's the inverse, means a smaller number means better performance. So don't ask me why. I often say that the building industry is the logic-free zone. So welcome to the logic-free zone, as this is your first exposure to the way we do things here. At any rate, a 0.3 U factor is probably the highest I would recommend for any California climate zone. And down in the 0.2 something, 0.27, 0.24 is even better. Similarly, the second parameter, the one on the right, solar heat gain coefficient, also referred to as SHGC. We want, generally speaking, less heat gain when we are improving our enclosures, because when we do a really good job improving the enclosure, we can risk overheating, especially if we've got a lot of west glass or unshaded south or even east facing glass. So it's important that we don't end up putting ourselves in a little hot box terrariums. Okay, and of course, shading devices can also be really tremendously helpful in reducing our cooling needs. So again, west-facing exposures are usually our biggest issues in California climates, or unshaded south exposures. So those are the areas where I would encourage you to look at those shading opportunities. Okay, so once you've done all the improvements you can make to the demand imposed by all those electrical things in your house, and done what you can with the enclosure, then we need to say, okay, how much electric capacity do you need now and in the future? So here's where we refer back to the list that I recommended you start with of all those electric things that you may add in the future. Because if you upgrade your electrical service once, you definitely don't want to do it twice. So it's important to consider whether you're going to need a new panel. If you're at 100 amps, going to 200, if you're at 200, going to 400. Alternatively, there are ways to minimize your need to bump up electrical service. I have a couple of colleagues who've kicked around the term the amp diet. And the idea here is, rather than increasing the electrical service at your home, you may be able to select for devices that have a lower demand on the electrical service. And a couple of these are these plug sharing devices I'm showing here right in the yellow box. These can allow sharing of a single outlet by two devices. And the other alternative is lower amperage equipment. And I'm showing those couple of options there in the green and the orange box. So I mentioned earlier the combined washer dryer, which is one way to reduce the draw on the electrical system. And then there's at least one, and I think more coming on the market soon, the lower amperage heat pump water heaters. So, and probably more, because this is an area, there's a huge amount of work being done out there in the energy industry right now to address the compelling need for us to electrify, the thousands, tens of thousands, hundreds of thousands of existing homes out there that presently have natural gas and propane service, so that we start to reduce our climate emissions and hopefully preserve a reasonable climate for ourselves and future generations. And so that means we've got it's really amazing the amount of work that's being done in this realm right now. So we're seeing fast evolution. It's really quite inspiring what's happening in this space right now. So something to keep in mind. After you figured out how you're going to address existing or increases to your existing electrical load and the impact on your home, then you'll be able to look at upgrades to heating and cooling systems. I've already talked about what those are. Just a few extra notes here about some of the things to keep in mind, and that is, oftentimes there's almost an exclusive focus on the efficiency of the box, of the heat pump, or whatever it is we're talking about. But there's little recognition that a lot of the overall performance of these systems comes from the effective design and installation of other aspects of the systems. For example, where they're located, or how the heat or water, in the case of a water heater, is actually distributed throughout the home, and how well those systems are installed. So it's really important to look at all those factors, and also to make sure the equipment is sized properly. A lot of particularly replacements that are done without benefit of pulling a permit, which is still frighteningly common. The sizing is basically, if you had a 3-ton unit before, we're going to swap in a 3-ton unit, even if you made significant efficiency improvements to your enclosure, which could mean your capacity needs are reduced to 2 tons or 1.5 tons. So it's really important to get a calculation done to size these units properly. And also, again, look at the system as a whole and other parts of the system and opportunities for improvement. And then finally, you've dealt with all those more challenging systems within the house to look at the renewable and battery opportunities. And I mentioned again, both installing on-site and looking at utility providers plan options. And just think it's worth mentioning there is still a 26% federal tax credit available that applies to both solar and batteries. And there may also be local incentives either through utility or the community choice aggregators in your area. So really important to look at those. And in the gray box on bottom left, I've listed several resources. The first two specifically about the tax credit, but the third one, which is a guide to home batteries that I helped along with a number of other volunteers to develop for Green Change, which is a nonprofit in Northern California. And it was really fun for me to work on because I knew some things about batteries before and learned quite a bit more working with the other folks on this. They're actually, we mostly, when we hear about home batteries now, it's the big ones, the Tesla batteries and the LG and so forth. But there are also some small and mid-sized batteries available that provide a less expensive and more limited option. So if you're not in a bracket that will allow you to consider the full price tag for the larger unit, it doesn't mean that battery backups are out of the question for you. It just means looking at some of these more modest systems. So I encourage you to look at those. And so the last thing is sort of thinking about phasing, besides walking through that sort of set of planning steps that I outlined, is to really sort of think about, okay, you probably can't do it all at once and, or in an ideal sequence. So I think it's really helpful to look at how long are your existing appliances likely to last, and maybe replacing some of them preemptively if they are approaching the end of their natural lifespan. Because what happens, let's say if you're looking at a furnace that's 12 years old and its life expectancy is 15 to 16 years, then repairing it, a repair, first of all, could have you without heat at a very unfortunate time. And secondly, you could be looking at the cost to repair that would go pretty far towards buying the replacement. So I think it's really smart to learn more about our appliance ages, because we tend to just wait until they fail. We're not taught to think about this ahead of time. One of the resources I've got for you is in the green bubble over there in the upper right, which gives you sort of a rubric to find out the age of your furnace, air conditioner, water heater. I suspect there are similar ways of decoding the ages of your other appliances with a little bit of sleuthing online, because most of these appliances, the age is encoded into the serial numbers. So that's a little known secret. Okay, and the other thing to think about is, are there some natural synergies that might occur? And I think a really important one is that anytime you get a trade contractor on site at your home, there's a mobilization cost. They're spending time to drive out to your site, to learn about your home and talk to you, maybe do some negotiations, and then their return travel time. So the more work you can have them done in a single visit or on a single contract, the more cost effective it's going to be for you. That's one way of thinking about this. And I've got several other sort of potential synergistic things that you could think about here too, about buying an electric vehicle. You're going to have significant fuel savings. Could some of your budget that currently goes towards vehicle fuel go towards some of your upgrades if the timing on this works well for you? So, and I think maybe the final one here, any other remodeling. Most people don't remodel exclusively to save energy or to reduce their carbon emissions. They have other architectural objectives that they want to achieve with remodeling. And yet those goals may open up great synergies and opportunities to do things that will also improve energy and carbon performance. So be sure and talk to any of your design professionals and family members about what things might make sense to do together. So once again, just want to emphasize that thinking about these things holistically has many, many benefits, and encourage you to be planning ahead and thinking creatively. So we got a final poll here and then we're going to be done. So Ian, if you want to pull up the options here, see how many of you are still plugged in and not thinking about dinner yet. Okay, we have only one person not yet voting. Maybe that's me.
Could be.
It could be. I'm not sure how this works. Okay, well, let's end the polling and we'll show the results. So the majority of you got this. I'm not going to say right, because like everything else here, there's no absolute answer. And depending on your home, your priorities, and what you have in mind, any of these answers could be correct. But I do like the one that says, let's look at the electric future in a holistic way first before we do anything else. So thanks for paying attention and considering all this as you move ahead. All right, and I've got some resources, more resources for you here. And each one of the documents that is linked here has embedded within it, somewhere between dozens and hundreds of additional resources. So the deeper you want to dive, we've got the resources for you to go there. So thanks so much for joining us this evening and listening and having good questions for me. And I certainly will be happy to stick around for more questions. So bring them on.
Yeah, we'll run through the 3C REN closing slides and then we can leave it open to see if anybody has some follow-up questions. I'm going to launch just a quick meeting usefulness poll that you guys are encouraged to fill out while I run through these slides. Any feedback and is always appreciated. So currently under 3C REN, we have the Energy Code Connect program, Building Performance Training program, and Home Energy Savings program. I'll go into them in the next couple slides, if you don't mind advancing. Perfect. So Energy Code Connect serves all building professionals. We offer services for everyone from plans examiners and inspectors to architects and contractors for both residential and non-residential application. Within ECC, we have 3 distinct services. We have the Energy Code Coach, which is an over-the-phone, online, over-the-counter, and in the field Title 24 consultation service meant to help building professionals navigate California Energy Code. We also offer trainings like we're sitting in today. And then we also offer quarterly regional forums that are kind of act as a networking opportunity. They typically cover policy and technical issues relevant to California Energy Code. Next slide, please. So the training we're all sitting in for today falls under the Building Performance Training Program. BPT serves current and prospective building professionals with trainings offered to architects, engineers, contractors, and real estate professionals. Mainly through BPT, we offer instruction. So we offer instruction covering technical skills as well as soft skills trainings. We also offer professional education credits, which we did offer AIA health, safety, and welfare units for today. I'll get into those in the final slide. Home energy savings is temporarily on hold, so stay tuned for the launch of our multifamily program in the next 2 months, and then single family program before the end of the year, hopefully. In the meantime, HES is offering DIY home energy savings toolkits at the county libraries in the region. you're welcome to check out our website for full details and a list of participating libraries. Next slide, please. So like I said, there was a unit and a half of health, safety, and welfare learning units for AIA. If you have any questions regarding learning units, you're welcome to email me. My contact email is listed here. Before the end of the week, we will be sure to get slides, a recording of today, and then a follow-up survey as well out to you all. Just to take a moment to look at some upcoming courses we have. On August 3rd, we have Easing the Non-Residential Plan Check on Energy Code and Commissioning. August 19th, What Energy Consultants Need to Know About Quality Installation. And then August 31st, we have Heat Pump Water Heaters and the Energy Code. I know a lot of these trainings are very Energy Code specific, but we will be uploading our Q4 offerings in the next month or two. So please keep your eyes peeled. You can visit our website or visit our website 3cren.org to find more event specifics and registration. Next slide. So that is all I have here for you all today. If there are any follow-up questions for Ann, you're welcome to ask them. We can either open it up as a free dialogue, or if not, we can close things up for this evening. Any remaining questions?
I just want to say that it's really an honor to have Ann presenting to us. She's renowned in this field, and we are very, very lucky. So thank you so much. It was great.
Was that Judy?
No, that was Karen Feedy.
Oh, thank you, Karen.
Certainly.
I appreciate that.
But Judy echoes that. Judy's here, and I'm happy to be here. Yeah, you don't waste any words, but you make it so practical and not common sense, but understandable. And it's good to see you again, Ann.
Thank you.
Hear you again.
Great to hear your voice too.
Awesome. Well, I think we can close things up for today. Again, thank you all for joining us. You will hear from myself and 3C Ren in the next few days with those deliverables.
Hi, Judy, Rachel.
Thanks all.
All right.
Bye.
All right.
Thank you, Ann.
All right, thank you. Hey,
Bye,
Ian, will you
everybody.
save the chat for me?
I will. Yeah.
Awesome. Thanks so much, everybody. Good night.